Let's begin with linear quadratic systems. When a system of equations consists of a linear and nonlinear equation, the system may have 0, 1, or 2 solutions. We can consider the following representations. There's no intersection between the two equations, so we have no solutions. In this case, there is one point of intersection. Therefore, in such a situation, there'll be one solution. And here we can see that the linear equation intersects the nonlinear equation in two different points, giving us two solutions. Now, linear quadratic systems can be typically solved using graphical or algebraic methods. Let's have a look at an example. So we're going to solve the following system: 8y equal minus 10x and y squared equal 2x squared minus 7. Now the second equation, here, that's given. And then we will take the first equation, 8y equal minus 10x, and we will make y the subject. So now I have two equations that are from the two original equations. And what I will do is I'll make the substitution y equal minus 5 over 4x in y squared equal 2x squared minus 7. So substitute y, and we get the following. After some algebra, we arrive here, and in further algebra, and applying the square root property, we find that x equals plus or minus 4. So minus 4 and plus 4. Then we can find y, like so, for x equals minus 4 and x equals 4. So what we do is we substitute x equals minus 4, x equals 4 in this equation here, or in this one as well. It's up to you. So then we have the solution as the point minus 4, 5, and also the point 4 minus 5. Now you could have also solved this graphically. So what would you do? You would graph the two equations that you start off with. So the red is 8y equal minus 10x, and the blue curve is y squared equal 2x squared minus 7. And if we look at the points of intersection, which gives us solutions, the coordinates are exactly the same as the solution that we found from solving algebraically. Here is a question for you to try. Solve the following system: y minus 3 equal to x, and y squared equals x squared plus 9. You may now pause the video and answer the question, and when you are ready to continue, please press play. You could solve the system algebraically or graphically, but in any case, you should arrive at the same two solutions. So minus 4 minus 5 and the point 0, 3. Moving on to quadratic systems. In the case of quadratic systems, the system may have 0, 1, 2, 3, or 4 solutions. Let's consider the following representations. We can see that the blue curve and the red curve do not intersect, so no solutions. In this case, there is one point of intersection, giving us one solution. In this representation, there are 2 points of intersection between the blue and red curves, so we have 2 solutions. Here we can see 3 points, giving us 3 solutions, and in a final representation, we have 4 points of intersection, giving us 4 solutions. Typically, we can solve such systems through the method of elimination, though other methods can also be used. Let's have a look at an example. Solve the system of equations x squared minus y squared equals 5 and x squared plus y squared minus 13 equals 0. So this is a quadratic system because we have 2 quadratic equations. Now, the first equation is given, and we will take the second equation and rewrite it, moving the minus 13 to the right-hand side. So now we have these 2 equations that are equivalent to our original equations. And we see that here we have minus y squared and plus y squared. So we can use the method of elimination by adding the 2 equations, so we eliminated the y variable. Now, After some algebra, we get that x squared equals 9, and applying the square root property, we find that x equals plus or minus 3. So then we substitute x equals minus 3 into one of our two equations, and we get that y equals plus or minus 2. So x equals minus 3 gives us 2 points. And also when x equals 3, we get y also equals plus or minus 2. So therefore, our solutions are the points minus 3, minus 2, minus 3, 2, 3, minus 2, and 3, 2. We could also solve this problem by graphing the two quadratic equations, and we see that the points of intersection of the two graphs are the same points that we found here by using the method of elimination. You can now have a go at the following question. Solve the system of equations, and here's your system. Again, it's a quadratic system. So you can pause the video and answer the question, and when you are ready to continue, you can press play. Once again, you could solve it algebraically or graphically, but in both cases, you would arrive at the same solutions. So we have these 4 points as our solutions.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below and send us a message now. Okay, with that said, let's get back to our lesson.
Moving on to systems of inequalities. Systems of inequalities can be solved by graphing. So let's consider the system. A quadratic system. We can graph each inequality, and we know that the solution is a region. So the first inequality, x squared minus y squared is less than 9, is given by the red region. So the red region satisfies this inequality, and the sky blue or the blue region satisfies the inequality x squared plus y squared is greater or equal to 100. So the solution of the system is the region where the red and the sky blue intersect. So that is the purple region. So therefore, the purple region represents the solution of the system. Now, if we consider the point 0, 11, we see that 0, 11 here is in the purple region. It's in our shaded region, the region that we want. So we can use this point to verify our solution. How do we do this? Well, we take the point and we check it in each inequality. So here's the first inequality. We substitute x is 0, y is 11, and the inequality says that minus 121 is less than 9, which is true. So therefore, the point 0, 11 satisfies the first inequality. Similarly, we take x squared plus y squared is greater or equal to 100. Upon substituting x is 0 and y is 11, the inequality tells us that 121 is bigger or equal to 100, which is also true. So the second inequality is also satisfied. So therefore, we can see that the point 0, 11 satisfies both inequalities, and from this, we've now verified that the purple region is the correct solution of the system. You can now solve a question yourself. You are asked to solve the system of inequalities by graphing, and here's your system. So you can pause the video and answer the question, and when you are ready to continue, please press play. Upon graphing the two inequalities and taking the intersected region, the solution is then the purple region, like so. And again, you can take a point inside the region, verify it to ensure that indeed any point in the region that you've identified satisfies both inequalities. Let's have a look at one more example where we have a quadratic with absolute value. So again, we're solving a system of inequalities graphically. And here we have an absolute value function and a quadratic function. But of course, it's still an inequality, so the approach is the same. So what do? We take the first inequality and the second inequality, and then we graph them and identify the feasible region. So y bigger or equal to the absolute value of 2x minus 4 is the blue region. And similarly, the quadratic y less than or equal to minus x squared plus 4x plus 2 is given by the red region. So the solution of this system is the intersecting region, which is the purple. This is where the blue, or the sky blue, and the red regions meet. So the purple region represents the solution of the system. Now, like before, we notice that the point 2, 4, among other points, is in the shaded or purple region. So what we can do, we can use this point to verify our solution. How do you do this? We substitute x equals 2, y equals 4 in each inequality, and we check if it holds. So now we will check. So y is bigger or equal to absolute value 2x minus 4. And when x is 2, y is 4, the inequality tells us that 4 is bigger or equal to 0, which is true. So this holds. Similarly, for the quadratic inequality, again, y is 4 and x is 2. And this inequality tells us that 4 is less than or equal to 6, which is also true. So both inequalities are satisfied by the point 2, 4. But the point 2, 4 is in the purple region, so therefore we have verified that the solution that we selected, or the solution that we said as being the purple region, is correct. And this is a final question for you to try. Again, you are solving a system of inequalities graphically. And here's your system, an absolute value function and a quadratic function. So you can pause the video, answer the question, and when you are ready to continue, please press play. After graphing each function, you should have been able to identify the intersecting region, and then you could always test that this region is the correct solution by testing a point in each inequality to see if it holds. And indeed it does. So the purple region is your solution here.